Hello, in this video, we present the synthesis of levetriracetam, which has been labeled with 4 tritium atoms, in accordance with its retrosynthesis as presented in our previous video. This isotopologue could prove to be useful for the investigation of the pharmacology and metabolism of this anti-epileptic drug. To put it briefly, the synthesis of levetriracetam that is labeled with tritium involves the preparation, through parallel synthetic routes, of 1 for the preparation of chlorinated hydroxylactone compound, which is commonly referred to as mucochlororic acid, prepared from furfural, and, on the other hand, the preparation of a chiral amino acid using diethyl oxalate and a Grignard reagent serving as precursors. Finally, the formation of the lactam ring and the subsequent incorporation of the tritium atoms through specific addition and substitution reactions, in which the primary source of the radioisotope is molecular tritium, ultimately completing the synthesis of this labeled drug, as we will see later. Preparation of mucochloric acid. The oxidation of 2-furfural with manganese dioxide in the presence of concentrated hydrochloric acid, it generates a series of intermediate compounds, beginning with the oxidation of the aldehyde group to form furoic acid, compound number 2. Manganese dioxide also oxidizes the hydrochloric acid, resulting in the formation of hypochlorous acid, which is added to the furane ring of 2 to give rise to intermediate 3. The isomerization of the double bond in 3 generates compound 4, which exists in equilibrium with its open form, compound 5. Manganese dioxide oxidizes the alcohol present in 5 to form alpha-oxo acid 6. This intermediate then undergoes a decarboxylation process utilizing an additional equivalent of manganese dioxide, ultimately leading to the formation of the carboxylic acid 7. The 1:5 relationship between the hydroxyl of the carboxyl group and the aldehyde group favors the formation of hydroxylactone 8. Finally, the incorporation of another chlorine atom generates mucochloric acid 9. Preparation of the chiral aminoamide. The addition of the Grignard reagent, specifically ethyl magnesium bromide 11 to diethyl oxalate 10, results in the formation of the alpha-ketoester 12. Its hydrolysis with oxalic acid generates alpha-ketoacid 13. The use of a biocatalytic system that utilizes NADH and the enzyme glutamate dehydrogenase in the presence of ammonium sulfate produces the chiral amino acid 14 with an excellent enantiomeric excess. The treatment of amino acid 14 with methanol in the presence of catalytic amounts of thionyl chloride quantitatively generates methyl ester 15. The reaction of 15 with ammonia gives rise to alpha-aminoamide 16. Preparation of the lactam. The reaction between lactone 9 and aminoamide 16 proceeds by means of nucleophilic addition of the amino group of 16 attacks the carbonyl of the lactone, opening the ring and forming intermediate 17, where the 1:5 relationship between the nitrogen atom and the carbonyl of the aldehyde group facilitates the intramolecular cyclization, leading to the formation of an imine as an intermediate, which is subsequently reduced using sodium triacetoxyborohydride to yield lactam 18. Preparation of molecular tritium. Tritium is generated through the process of bombarding lithium with neutrons, which subsequently leads to the creation of both helium and tritium. The neutron bombardment of ceramic containing lithium zirconate produces ionized tritium with a positive charge that, upon trapping an electron, will form a tritium radical and, finally, produces molecular tritium that is diffusing out from the material. When treating the unsaturated lactam 18 with molecular tritium in the presence of palladium on carbon as a catalyst, a series of substitution and addition reactions proceed. On one hand, the substitution of the chlorine atoms by tritium, and on the other hand, the addition of tritium to the existing double bond, which leads to the formation of the desired labeled drug. In summary, here are the main raw materials and their structural contribution. Thank you for your attention.